Hello everyone, thank you for tuning in. Today's video is about grounding measurements. As you know, establishing the grounding scheme is the foundation for an ESD control program. While several options are available, it is important to know how to take the measurements. How to measure each of the options will be discussed in this video. To demonstrate these grounding measurements, we will be using a grounding demo box that contains 5 grounding scenarios or problems, a digital multimeter, and a ground integrity meter. In the first slide, you will see a desired ground where the resistance is less than 1 ohm. In the next slide, you will see an open circuit where the wire is completely disconnected. The resistance there will read infinite or overload. As you can see in the lights below the drawing, the digital multimeter reading will show open. The ground integrity meter will also show open, indicating that both of these meters will work when encountering this situation. In this slide, you'll see a situation where there is higher than normal resistance. Maybe it's caused by oxidized connections. As you can see, the device under test has a lot of oxidation there around the connection, as well as at the earth ground point. As you can see in the lights below, the digital multimeter will read 100 ohms, and the ground integrity meter will also read 100 ohms, indicating that both of these meters will work great when encountering this situation. In this slide, you will see that there is a long coiled wire, and as indicated in the lights below, the digital multimeter reading will read 1 to 2 ohms, which is the actual resistance of that coiled wire. However, the ground integrity meter will read 25 to 35 ohms, which is incorrect. The reason this is happening is because the digital multimeter outputs a DC signal when testing resistance. However, the ground integrity meter outputs a 600 Hz AC signal. And as you know, when you run AC electricity through a coil, you get inductance, and that inductance interferes with the correct reading on your meter. So as you can see, a digital multimeter would be preferred when encountering this issue. In this slide, we have a situation where there's electrogalvanization across the ground wire. As you can see, coming from the device under test, there's a copper wire. Then it meets a steel wire, then a tin lead wire, and then whatever wire is going to ground. But as you can see, everywhere there's a junction of 2 dissimilar metals, you get a millivolt DC current created, and that's also known as the thermocouple effect. So as indicated in the lights below, the digital multimeter reading will read greater than 100 ohms, which is incorrect, and the ground integrity meter will read 10 ohms, and as you can see with the 10 ohm resistor in the line, we should only have 10 ohms of resistance there. The reason this is happening is because, again, the digital multimeter outputs a DC signal, and those millivolt thermocouple effects at each junction are interfering with your reading, whereas the ground integrity meter outputs an AC signal, and it completely ignores all the millivolt DC signals created on that line. In the last slide, we have a known resistance of 1 meg ohm. And as you can see in the lights below, the digital multimeter will read 1 meg ohm, and that is the correct reading. However, the ground integrity meter will read open or overload, and that is simply because the ground integrity meter can only read a maximum resistance of 1,999 ohms. This 1 meg resistor might simulate something like your ESD wrist strap. Alright, so let's get into the demos now. As you can see, I've got my ground integrity meter here, and I also have my Fluke digital multimeter set in ohms or resistance mode. As you can see on the left, I have my ground integrity meter probe, and on the right, the digital multimeter probe. I have connected my probes to ground via this ProStat grounding cube, and so we'll go ahead and measure A, which will be an open circuit. And with both meters, we should read open. As you can see on the ground integrity meter, it's not getting any reading at all, which means that it's open. Now we switch to the digital multimeter, and we have overload as well, showing that that is an open circuit. Next, we'll go on to letter B, which is high resistance. And with the digital multimeter, we should get 100 ohms. And as you can see, we're getting 99.37, and that's close enough. Now let's try that with the ground integrity meter. As you can see, the ground integrity meter is reading 98.3 ohms, which again is close enough. So now we'll move on to letter C, which is a long coiled cable. And here you'll see that we get the proper resistance reading of 2.24 ohms with the digital multimeter. However, when we run the AC current through it with the ground integrity meter, we are going to get a far different reading. As you can see, about 29.5 ohms, which is incorrect. And again, that's because the AC current from this ground integrity meter is causing inductance in our coil. Next, we will do letter D, and that is the electrogalvanization issue, where we're getting the millivolt thermocouple effect at each junction in the dissimilar metals. So the digital multimeter is going to give us the incorrect reading of about 47k ohms, which is definitely incorrect. But when we test it with the ground integrity meter, we will get the proper resistance of 10 ohms. Because this meter is outputting an AC signal, it completely ignores any of those DC millivolt signals created by the dissimilar metals at those thermocouple effect junctions. Next, we'll do letter E, which is a known resistance of 1 meg ohm, similar to your ESD wrist strap. And the digital multimeter will give us the correct reading of 0.99 meg, which is basically 1 meg ohm. However, when we test it with the ground integrity meter, it will just continue to show open, just like letter A, and that's because the ground integrity meter can only read up to 1,999 ohms. I hope this helps you guys when you're out in the field encountering problems, and if you have any questions or comments, feel free to call us, email us, or look us up on the web at www.xfabion.store or www.xfabion.com. Have a great day.